In this video, we are going to learn how to calculate the thermal energy Q absorbed or released by an object and how to find their specific heat capacity C. The question says, when you turn on the hot water to wash dishes, the water pipes heat up. How much thermal energy is absorbed by copper water pipe with a mass of 2.3 kg when its temperature is raised from 20 degrees Celsius to 80 degrees Celsius? Let us first write down what is given to us. Question has given me the mass of copper pipe, which is 2.3 kilogram. I have the initial temperature, which I will call T1, 20 degrees Celsius. And we have the final temperature T2, 80 degrees Celsius. They want us to find what is the thermal energy absorbed by copper. So thermal energy Q is given by mc times delta T, where m is the mass of the object, C is its specific heat capacity, and delta T is the change in temperature. So change in temperature delta T you can write as the final temperature minus the initial temperature, T2 minus T1. Specific heat capacity, on the other hand, they should give this to you in the question, or they will give you a table like this that has specific heat capacity of different substances. Here I have copper, so I will find specific heat capacity of copper here, which is 385 joule per kg Kelvin. So let us write down C from the quantity given to us. C for copper will be 385 joule per kg Kelvin. Now substitute in your expression for Q. Mass of copper is 2.3. Specific heat capacity is 385. Change in temperature, final minus initial, so 80 minus 20. That will give me the thermal energy absorbed by copper as 53130 joule, which I can write as equivalent to 5.3 times 10 to the power 4 joule. Question 2. Electrical power companies sell electrical energy by kilowatt hour. 1 kilowatt hour is equal to 3.6 times 10 to the power 6 joule. Suppose that it costs AED 0.30 per kilowatt hour to run your electric water heater. How much does it cost to heat 75 kilogram of water from 15 degrees Celsius to 43 degrees Celsius to fill a bathtub? Let's write down what they have given us. They have given you the mass of water, which is 75 kilogram. And you are using an electric water heater to heat this water from an initial temperature of 15 degrees Celsius to 43 degrees Celsius. I want to find how much will it cost me to do this. So let us first find out how much thermal energy is required to raise the temperature of water. Thermal energy is given by Q equals m times C times delta T, where m is the mass of the water, C will be its specific heat capacity, and delta T is the change in temperature. So I can rewrite this as mc T2 minus T1. Mass of the water is 75 kilogram. Specific heat capacity of water I will find from the table. It is here, water is 4180. So times 4180. And change in temperature will be 43 minus 15. When you solve this, you get the thermal energy required to heat the water as 8778000 joule, which is equivalent to 8.8 times 10 to the power 6 joule. I need to convert my thermal energy from joule to kilowatt hour because the commercial unit of energy is kilowatt hour. And when I have to find my cost to heat this, I will have to use the conversion to kilowatt hour to find the total cost. We know that 1 kilowatt hour is equal to 3.6 times 10 to the power 6 joule. So if I want to convert this thermal energy from joule to kilowatt hour, I have to divide by this number. So my thermal energy in kilowatt hour cube will be equal to 8.8 times 10 to the power 6 divided by 3.6 times 10 to the power 6. And when you do that, you get your energy in kilowatt hour as 2.44 kilowatt hour. Now the question says that 1 kilowatt hour is costing me 0.30 AED. So how much will 2.44 kilowatt hour cost me? So you just need to multiply these two numbers together to find the total price. So 2.44 kilowatt hour will cost me 0.30 times 2.44. That will come out to be 0.732 AED. So whenever the question wants you to find the cost of something, they will give you the rate per kilowatt hour in the question. First thing you must do is find the thermal energy required to change the temperature of water. Then convert that thermal energy from joule to kilowatt hour. Once you get your energy in kilowatt hour, then you can find the cost of this many kilowatt hour because they will give you the cost of 1 kilowatt hour. Just multiply that cost with your total thermal energy and you will get your final answer. Question 3. A car engine's cooling system contains 20 liters of water. 1 liter of water has a mass of 1 kilogram. First part of the question is asking you, what is the change in temperature of water if 836.0 kilojoule of thermal energy is added? So let's solve this step by step. I will first write down what is given to me. They have given me 20 liter of water. So 20 liter is the volume of water, which is 20.0 liter. And question says that 1 liter of water has a mass of 1 kilogram. That means 20 liter of water will have a mass of 20 kilogram. If 1 liter is equivalent to 1 kilogram, then 20 liter will be equal to 20 kilogram. And first part of the question says that if I add a thermal energy of 836.0 kilojoule, what is the change in temperature of water? I want to find what is the change in temperature. So we will be finding what is delta T. First, I will convert this thermal energy from kilojoule to joule. Kilo means 10 to the power 3 or 1000. So I will multiply this number here with 10 to the power 3 to convert it to joule. So let's find the change in temperature for the first part of the question. We know that thermal energy Q is given as mass times specific heat capacity into the change in temperature. If I want to find the change in temperature, I need to get rid of M and C. Since M and C are multiplied to delta T, when I move them to the other side of the equation, I need to divide by them. So we can rewrite this as delta T equals Q over M times C. Q is 836 times 10 to the power 3. Mass of the water is 20 kilogram. Specific heat capacity of water we will find from the table here. Water is 4180. And when you solve this, you get your delta T to be equal to 10 Kelvin. Now let's discuss part 2 of the question. Part 2 says, suppose that it is winter and the car's cooling system is filled with methanol. Density of methanol is 0.8 gram per centimeter cube. What would be the increase in temperature of methanol if it absorbed 836.0 kilojoule of thermal energy? So here now, instead of water, the cooling system is filled with methanol. But we still know that the capacity of cooling system is 20 liter because initially we filled it with 20 liter of water. So volume of the cooling system still remain the same, which is 20 liter. Here they have given me the density of methanol. Density is, I can write as the notation rho, which is 0.80 gram per centimeter cube for methanol. If I want to find the change in temperature, I will need the mass of methanol. And we know that density is mass over volume. We can multiply density with more volume to calculate the mass of the methanol. So I will rearrange this term and write mass of methanol will be the density times volume. So when I'm finding the mass, I will just multiply density with volume to get the mass. So let's calculate mass of methanol. It will be density, which is 0.80 times the volume 20. That gives you 16 kilogram. Question again wants me to find what is the change in temperature of methanol. So let's start with the same expression for thermal energy. Thermal energy Q is given as mass times specific heat capacity into the change in temperature. If I want to find the change in temperature, I need to divide with M and C on both sides. So we get delta T equals Q over M times C. Q here is the same 836.0 kilojoule. So I need to convert this kilo to joule. I will multiply it with 10 to the power 3. So let's substitute 836 times 10 to the power 3 divided by mass of methanol is 16. Specific heat capacity of methanol we will find from the table. Methanol is here and the value is 2450. And when you solve this, you get the change in temperature as 21 Kelvin. Now part 3 of the question is asking us, which coolant, water or methanol, would be better to remove thermal energy from car's engine? Explain. So how do you identify which coolant will be better? The coolant that brings about less change in temperature would be better to remove thermal energy from the car's engine. So since change in temperature of water is only 10 Kelvin, whereas change in temperature of methanol is 21 Kelvin, in this situation, water will be a better coolant than methanol. Question 4. A 1 times 10 to the power 2 gram aluminum block at 100 degrees Celsius is placed in 1 times 10 to the power 2 gram of water at 10 degrees Celsius. The final temperature of the mixture is 26 degrees Celsius. What is the specific heat of aluminum? So I have mass of the aluminum block, its initial temperature, mass of water, and the final temperature of the mixture. So let me write this down. We have mass of aluminum block. I will write it as Na. 1 times 10 to the power 2 gram. We will convert this to kilogram. And when you convert this to kilogram, you will divide by 1000. That will give me 0.100 kilogram. Same with the mass of water. Mass of water I will denote with MW. It's the same value. So when I convert this to kilogram, I will get 0.100 kilogram. Same thing, you divide with 1000. Initial temperature of aluminum block, I will write it as T1 for aluminum. is 100 degrees Celsius. Initial temperature of water, I will write T1 for water is equal to 10 degrees Celsius. And the final temperature of the mixture, I will write as T2, which is 26 degrees Celsius. We need to find what is specific heat of aluminum. So if you want to find specific heat of aluminum, we need to find what is the heat lost by the aluminum. If I sketch my situation here, you have water and you place a block of aluminum inside the water. Aluminum initially is hot. When you place it inside the water, water will gain heat energy from aluminum. So heat energy for water, it will increase. And aluminum is losing its heat energy. So heat energy for aluminum will decrease. The heat energy gained by water is equal to the heat energy lost by aluminum. So if I can find the heat energy or the thermal energy that is gained by water, I can make it equal to the thermal energy lost by aluminum. So let us first find out what is the thermal energy gained by water. I will call it QW. We know thermal energy is mass times specific heat capacity into delta T. So mass of water, specific heat capacity of water, and delta T will be final temperature minus initial temperature of water. Let us substitute. Mass of water is 0.1 kilogram. Specific heat capacity of water from the table is 4180. Change in temperature. Final temperature of water is 26 for the mixture. Initial temperature of water was 10. And when you solve this, you get heat energy gained by water to be equal to 6.27 kilojoule. Now this heat energy gained by water is equal to the heat energy lost by aluminum. And since this heat energy is lost for aluminum, when I write the same Q for aluminum, I have to take it negative. Negative because aluminum has lost this heat energy. It has not gained, it has lost it. I'm going to use the same equation to calculate specific heat of aluminum. So let's write specific heat of aluminum will be mass of aluminum times its specific heat capacity times the change in temperature for aluminum. If I want to find specific heat capacity, I will divide energy lost by aluminum with mass times the change in temperature. So QA over mass times the change in temperature delta TA. QA is negative 6.27 kilojoule. So that kilo I will convert to joule by multiplying with 10 to the power 3. Mass of aluminum is 0.1. Change in temperature, aluminum goes from an initial temperature of 100 to a final temperature of 26. So 26 minus 100. And when you solve this, you get specific heat capacity of aluminum as 847 joule per kg Kelvin.